Hello everyone, I am Seshivitya, working as Associate Professor in the Department of Electronics and Communication Engineering at R.M.K College of Engineering and Technology. So today we are going to discuss demultiplexer in digital electronics subject. So what is demultiplexer? So demultiplexer means already we have discussed what is multiplexer. Today we are going to discuss demultiplexer. So it is just opposite to that of multiplexer. Multiplexer is nothing but many to one, but here it is demultiplexer is one into many. So demultiplexer is basically it's a combinational circuit which will take the information from one input and transmitting the same to over the one of the several outputs. So it receives the information on a single input and transmits the same information on a several 2 power n output lines and which will have n selection lines. And this demultiplexer it is also called as distributor, or we can call it a serial to parallel converter. Why? Because that is one of the output terminal that can be selected based upon the selection lines, so that input signal that can be distributed among one of the output terminal. That is why it is called as distributor. So next comes design of 1 to 4 demultiplexer. So 1 to 4 demultiplexer, as the name implies, which will have one input and four outputs, and at the same time which will have the two selection lines. And based upon the selection line values, either of these output terminal will be selected. So this is the truth table for the 1 to 4 demultiplexer. S1, S0, D in, that is data in, and four outputs Y0, Y1, Y2, Y3. And the first column represents enable. So when enable is equal to 1, which means the actual data is given to the 1 into 4 demultiplexer. And enable is 0 means irrespective of the selection line inputs, we'll be getting that output as 0. Why? Because there is no data is given to the input terminal. Once the circuit is enabled, then we will be giving that S1 and S0 values. So when both S1 and S0 is 0, then whatever the data which is available in this data in, that will be distributed through the output Y0. Why? Because the selection line inputs are 0, 0. And suppose selection line input is 0, 1, then that particular data, that is data in, that will be distributed through Y1 and so on. So based upon this S1 and S0 value, we'll be getting that output either among the one of the output of output terminal. And here this, as I told you, and when both S1 and S0 is equal to 0, then we'll be getting that output through Y0. When it is 0, 1, then we'll be getting that output through Y1. When it is that the selection line input is 1, 0, then we'll be getting that output through Y2. And finally, when both the selection line inputs are as equal to 1, then we'll be receiving that output through Y3. So finally, you can just able to draw the logic diagram for the 1 into 4 demultiplexer. Next comes the design of 1 to 8 demultiplexer. So as the name implies, which will have one input and 8 outputs. And here this 8 outputs, it distributes one input line to 8 output lines based upon the selection line inputs. And this 1 to 8 demultiplexer which will have 3 selection line inputs, that is S2, S1, S0. So based upon this 3 selection line input values, the either of this output terminal will be selected. So we'll be getting that output through that particular output terminal. And this is the logic diagram for 1 into 8 demultiplexer. So we'll be getting distinguished outputs from Y0 to Y7 based upon that selection line inputs S2, S1 and S0. Next one is a design of larger multiplexers using smaller demultiplexer circuit. So since already we have designed 1 into 4 demultiplexer and 1 into 8 demultiplexer, suppose if you want to design a larger multiplexer circuit, then we can just use that smaller demultiplexer circuits as well. Say for example, this is a design of 1 into 8 demultiplexer using two 1 into 4 demultiplexer circuit. So this is the actual, that is actually will be just having that one input and 8 output terminal for the 1 into 8 demultiplexer. So instead of that straight away, that is instead of using that 1 into 8 demultiplexer straight away, we can just use two 1 into 4 demultiplexer circuit. So that the data input that will be connected to data input of first and second 1 into 4 demultiplexer circuit. From the first 1 into 4 demultiplexer circuit, so we'll be having that 4 outputs, and similarly from the second set we'll be having the remaining 4. So totally 8 outputs. And for this 1 into 8 demultiplexer circuit, we know that there should be 3 selection line inputs, and that can be indicated as A, B, C. So that can be given to this S1. And but for that 1 into 4 demultiplexer, you should have two selection lines, S1 and S0. And for this 1 into 4 demultiplexer also, there are two selection lines, S1 and S0. So that can be connected to B and C. And this A, in here this is enable, and this is also enable input. So enable is equal to 0, then the first one is enabled, and suppose A is equal to 1, then the first demultiplexer which will be disabled. So based upon that, we'll be getting either this output or this output. So likewise, we can just design any larger demultiplexer circuits using smaller demultiplexer circuits. Second one is implementation of 1 into 16 demultiplexer using 1 into 8 demultiplexer and 1 into 2 demultiplexer circuit. So here it is, totally there are 16 outputs. 1 input, 16 outputs. So that it is called as 1 into 16 demultiplexer. So this can be constructed by using two 1 into 8 demultiplexer. So for a individual 1 into 8 demultiplexer, we know that which will have 8 outputs, 1 input and 3 selection lines. Similar way, for the second demultiplexer circuit, 1 into 8 demultiplexer circuit, again which will have 8 outputs, 1 input, 3 selection lines. And this that is input for this 1 into 8 demultiplexer is from the 1 into 2 demultiplexer. So since it is an 1 into 2 demultiplexer, which will have 1 input and 2 outputs. And outputs from this 1 into 2 demultiplexer that can be connected to the upper and lower 1 into 8 demultiplexer circuit. So if you just consider this whole circuit diagram, which will have 1 input, 16 outputs, and it should have 4 selection lines. So 3 selection lines are here. The one more selection line is here. So likewise, we can just construct any larger demultiplexer circuit using smaller demultiplexer circuits. So next we are going to discuss how to implement any Boolean function. So next one is implementation using demultiplexer circuit. So the question is implementation of full subtractor using 1 into 8 demultiplexer. So since the implementation of full subtractor, so we should know the truth table for full subtractor. So for full subtractor, we know it's in 3-bit addition, that is a subtraction of 3-bit. So A, B, B in, and outputs are difference and borrow out. So first we should construct the truth table. So from the truth table, we can able to write what is difference and borrow out. So difference is equal to 1 for the combination 1, 2, 4 and 7. So that we can write it as difference D is equal to f of A, B, C is equal to summation of minterms 1, 2, 4, 7. Similarly, we can just write it for borrow out also. So borrow out is equal to f of A, B, C and summation of, that is S of P, that is sum of product term of 1, 2, 3, 7. So now we can able to implement using 1 into 8 demultiplexer circuit. So since it's an 1 into 8 demultiplexer, so which will have only one input, that is D in, that is equal to 1. And 1 into 8 demultiplexer means 1 into 2 power 3, where 3 denotes selection lines. So here the selection lines S2, S1, S0. So according to this, the variables are ABC, so that we can write it as ABC. And that is from the demultiplexer circuit, we will be getting 8 distinguished that is mean terms. So what is the question is, we are going to implement the full subtractor using 1 into 8 demultiplexer. So what is the difference? It is sum of product term of 1, 2, 4, 7. So you can just connect on OR gate. So 1, 2, 4, 7, that can be connected to the input of first OR gate. So that output is equal to difference. And similar way borrowed. Borrowed is nothing but sum of product terms 1, 2, 3, 7. So it is sum of product terms, so that we'll be using OR gate. So 1, 2, 3, 7. That can be given to the input of second OR gate. So the output will be B out. So likewise, any combinational circuit or any circuit that can be implemented using demultiplexer circuits. Next comes applications. So applications of demultiplexer, and here it is extensively used in microprocessor, or we can call it as computer control systems, such as selecting different input-output devices for the data transferring purposes. And then which will be used for the selecting different input-output devices for data transfer also. And choosing different banks of memory, and we can just use the demultiplexer circuits. And one more thing is, depends on the address, enabling different rows of memory chips also possible by using this demultiplexer. and it is also possible to enable the different functional units. And speaking, and this is one of the day-to-day life application of demultiplexer. Say for example, there is a single source. Consider our normal laptop. Okay, so we are going to connect the demultiplexer. So we know that it's 1 to many. So the single laptop that can be connected to many output terminals, that is many output devices. So in between there will be a demultiplexer. So demultiplexer, and which is nothing but it's a data distributor. Okay, so the single source that can be distributed through the 4 output devices. So first one is nothing but Bluetooth speaker, second one is fax machine, third one is printer, and last one is smartphone. So this laptop, it can be connected either of these output terminals based upon the selector output, that is selector line. Selector line inputs. If it is 0, 0, for example, the first terminal, that is the first device will be connected, that is D0 will be connected. Suppose if it is selector input is 0, 1, then the fax machine will be connected to the laptop. Suppose if this selector input is 1, 0, then printer will be connected to the laptop. Suppose if the selector input is 1, 1, then the smartphone will be connected to the laptop. So likewise, we can just connect or we can just distribute the data from single source to the many devices. So this is the best example for the demultiplexer. So I hope everyone understood about this demultiplexer. Thank you for your patient listening.